welcome back to my YouTube channel. So today we are going to solve day 17 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem 670 maximum swap. Okay, so in this problem you are given an integer num. You can swap two digits at most once. Okay, to get the maximum valued number we have to return the maximum valued number you can get. All right, so see example number one. This is my num given to us, right? Number given to us. So if I just swap this 2 with the 7, I will get this number 7, 2, 3, 6, and this number is greater than this number, right? So we can give this output. Can we do anything else here? 2736 is the number. So can I swap this 6 with 3? Then I will not get a bigger number than this 723, say 6, right? So this is the best possible case. Okay, and we can just swap once only, right? You can swap two digits at most once only, right? So that is why the output is 7236. Okay, see here 9973. So can I swap any two numbers here? 9 with 7, I can't do that, right? There is no use to swap these two as well, 9 and with 9. Okay, because always I will get this number only 9973. Okay, so there is no swap required here in the example number 2. Okay, so now how we are going to solve this problem? So let's understand the approach for this one. Okay, so let's take this example. Number is 2736. This is my number. Okay, 2736. Okay, so first thing that you need to do here, you have to convert this number to the char array. Okay, so in this char array, okay, so let's say digits. Okay, digits is my char array. Okay, so in this I will just add this number 2, 7, then we have 3, and then we have 6. Okay, so this is first thing. Then you have to create one last array. Okay, so here let's do that. So let's say this is my last array, and here uh, I will have total index 10 indexes. Okay, so let's see how many indexes we have got here. Let's say this is index 0, this is index 1, this is index 2, index 3, index 4, index 5, index 6, 7, 8, and this is index 9. Okay, so now what we need to do, initially you know that this last array, okay, this is my last array. So we have digits from 0 to 9 only, right, in a number 2, 7, 3, 6. So we have digits only from 0 to 9, right? So these are the digits 0 to 9. Okay, so initially let's say I have filled all these with 0, 0, 0 initially. Okay, all these are 0. Okay, now see here, this 2 is at index 0, this 7 is at index 1. Okay, for this digits array, this 3 is at index 2, and this 6 is at index number 3. Okay, so now what I need to do here, I need to add these indexes. Okay, these indexes in my last array. Okay, so here this digit 2 is at 0 index, so here I have to add 0. Okay, remove it and update it with 0. Okay, it was 0 only, so here I have just updated it with 0. Okay, this 7 is at index 1. Okay, so here in this 7 I am just filling index 1. Okay, this 3 is at index 2. Okay, so digit 3 is at index 2. All right, update this. This 6 is at index 3. Okay, 6 is at index 3, update this. So done. Okay, this is what we have got. Okay, so now what we need to do, okay, once this is done, then I have to iterate over my digits array. Okay, this 2, 7, 3, 6 one by one, starting from left side. Okay, like this. So first digit here is what? First digit here is 2, right? 2. First digit is 2, and 2 is at which index? 2 is at I is equal to 0. Okay, at this index, right? I is equal to 0, we have 2. Okay, now I have to check the I have to run one more for loop. Okay, where let's say int d. Okay, d is 9 and d should be, okay, and d, okay, this d should be greater than this digits of I. Okay, digits of I is 2. Okay, 2 digits should be greater than 2, and here d minus minus. Okay, so I have to check from right side. Okay, from here to here I have to check. So I have to find a greater number than this 2, right? I have to find any greater number than this 2. Okay, so greater number than this 2 is going to be 3 or 4 or going to be 5 or going to be 6 or going to be 7 or going to be 8 or going to be 9. Okay, so these are the possibilities, right? So that is why I am running this loop. Okay, from d is equal to 9 to d is greater than 2. Okay, digits. Okay, so now inside this I have to check if my last of d is greater than I. Okay, so I is 0 and last of d 9. I am checking from here. Okay, I have to find the greatest number. Okay, 9 is 0. Last of d is 0 only, right? Last of d here is 9. Okay, so 0, I don't need to do anything. I have to check 8. No. Then I found that this last of d, okay, last of 7, and last of 7 is 1, and 1 is greater than 0. Okay, so what does this mean? So we have to swap digits of I. Okay, this digits of I, this value, okay, 2 with the digits of last d, digits of last d is 1. So here at 1 this 7 is available. Okay, so with this 7 we have to update. Okay, so after that, after swapping, we have to just do the early logout. Okay, so here 7 I am swapping with the 2. Okay, 7, 2, then 3 and 6. Okay, this is what we need to do. Only once we have to do the swap, right? And we did the swap, okay, of this first index, because for this I have found a greater value. Okay, and I'm searching from the this side only, right? 9, 8, 7. Okay, and this is the greatest number, 7. Okay, if 8 is there, then I will swap that with, right? I'm not checking from this, I'm checking from this, because I don't want to swap this 2 with this 3. Okay, that is why this 6 na, this 6 is there, this 6 is there, so add 3 index. So I don't want to swap this 2 with the 6, because I know 7 is greater, right? So that is why I'm checking from right to left. Okay, after swapping it, we have to just log out, or you can say break the statement. Okay, we have to just return the result as an integer. Okay, so this is what we are going to get, 7236. We did one swap, at most one swap, and then after that just convert this to a number. Okay, so in the end just return this 7236. Okay, so that's what we need to do as part of this problem. Okay, so now let's write the code. The code is also going to be very simple for this one. Okay, whatever I have explained, I am going to do the same things. Okay, so char digits is equal to, we have integer given to us, right? So what I need to do, I have to convert this integer to string. Okay, what I'm going to convert to string, we have to convert this num to string, right? Num. Okay, so but here I'm creating char of digits array, so convert this. Now we have got the string. Okay, now we have to convert this string to char array. So here to char array. Okay, that's it, right? This is done. Then create one last array. Okay, for all the digits from 0 to 9, we have these digits, right? New int 10, size is 10, 0 to 9, right? And then we have to record the last occurrence of each digit. Last occurrence. Okay, let me add the comment here. Record the last occurrence of each digit. Okay, so here run one loop for int I is equal to 0, I is less than digits dot length, and here I plus plus, and inside this last of digits of I minus 0. Okay, so we have to just update the index, right, is equal to I. Now what does this mean? Last occurrence of digit, each digit. Okay, so see this example, 29973. Okay, so 9 is appearing at 0 index. Okay, then 9 is also appearing at index 1, right? So what I have to do, last of digits of I. Okay, digits of I is 9, 9 minus 0. Okay, last of digits of I, digits of I 1. At 1 we have got 9, 9 minus 0, 9. Okay, so here at last of 9 I have to update this 1. Okay, not 0. I have to initially I update at 9 index 0. Okay, initially I update at this 0, then later on I have to update it 1. Okay, because I have to update the last occurrence, right, last occurrence. So this is what we need to do. Okay, this is the all right. Now after that what we need to do? Okay, so after that we have to try to find the first digit which can be swapped with the larger digit. Okay, so let me add the comment here as well. Try to find the first digit that can be swapped with the larger digit. Okay, so this is what we need to do now. Okay, so here run one loop for int I is equal to 0, I is less than digits dot length I plus plus, and here after that we have to run one more loop for int d. Okay, so we have to check the greater number only. Okay, d starting from right, d is equal to 9, and here I have to check d is greater than, okay, digits of I. Okay, get that particular number minus 0, we have to subtract. Okay, 0 character. Okay, so that we can get a number, d minus minus. Okay, and inside this we have to check if last of d, okay, is greater than I. Okay, all right, so here what we need to do? Okay, in this case we have to swap digits of I with digits of last of d. Okay, so create one temp variable is equal to digits of I, take this number, store this number in temp. Okay, then we have to update this digits of I with digits from my last of d. Okay, this is what we need to do, and then we have to update digits of last of d with the temp. Okay, normal swap we are doing, right? So here char is equal to digits of I temp. Okay, in temp I have added this 2, temp I have added this 2, and here then I am updating digits of I. Okay, this 2 I am going to update it with digits of last of d, last of d here. Okay, last of d. Okay, this 1, so 1 I am passing here. Okay, digits of 1, so digits of 1 is 7. Okay, 2 I'm swapping with 7, and then after that I am updating this 7 with temp. In temp I have stored 2. Okay, normal process. Okay, normal swapping operations. Okay, this is done. Then we have to turn the result as an integer. Once this is done, okay, only one time we have to swap, right? So here return integer dot parse int. Okay, and here new string. Okay, I am converting it to new string first, these digits, then I am converting that to an integer number. Okay, this is the new string of digits. And here, if no swap was made, we have to return the original number, right? So here I have to use return num. Okay, this is done. Okay, and here that's it. Okay, okay. Okay, so now let's run it. All the test cases has been accepted. Now let's submit it. So I hope that you guys are able to understand today's problem. Time complexity, let's see, it is showing as O of n. So for O of n simply means that the total number of digits that we have. Okay, because this is operation that we are only going to run for n times, so it doesn't matter if digit of length is very much large, let's say n, okay, large value, then it only depends on the length of this one. Okay, so that is why time compressed is going to be O of n. So I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.